Hey, fifth grade. This is our new week. We have a test this week, and then we're going to start our next chapter. So for Monday, we're going to do some review. So I'm going to go through a couple of sample problems with you. We're going to be on page 92, and you're going to be doing 1 through 20 today. So it's a good bit, but we really need that practice because we had 2 weeks off. So we need to go back to that. So 92 is where I'm going to be. And I'm going to quickly just go through a couple with you, and then I'll let you guys go and work on it. So 1 through 20. On number 1, let's do that one together. I'm going to do a sample problem with you. So it gives you 63 divided by 9. We know that equals 7. Then this is where they have the patterns, where we have something like this. That's where I underline and I divide the non-zero digits, and I get 7, and I add that 0 over to this side. So if I had 6,300 divided by 9, I would do 63 divided by 9 is 7, add those 2 zeros over. Okay, remember those are the pretty easy ones we did with the patterns. So that's going to be 1 through 8. Those are going to be how you do 1 through 8. Sorry, it's the middle of carpool on Friday, so you might hear Miss Becky on the intercom and people might come in, but we'll push through. 9 through 20 is going to be straight division, so let's do number 9 together. Number 9 would be 9 into 3,027. So first 9 goes into 30. 9 goes into 30 3 times. 9 times 3 is 27. Subtract that, I get 3. Bring down the 2. 9 goes into 32 3 times. 9 times 3 is 27. 32 minus 27 is 5. Then bring down the 7. 9 goes into 57 6 times. 9 times 6 is 54, run out of room, but we get a remainder of 3. Don't forget to put your remainder at the top. I want to do, actually, I'm going to save the next one for Tuesday's video. Tomorrow, you'll do some more review with division going into the 2-digit divisors. So we'll do a little bit of that together. But for today, basic division and division patterns, it's really, really simple. So remember, this is what you're going to be working on for today. So remember to do this test on Wednesday. That was Mr. Shane that just came in, sorry. So I'm going to clear this out, and I'll see you guys for Tuesday. All right, Tuesday's video. Today you're going to finish up the review. You're going to do page 92, numbers 25 through 32, and 41 through 44. So let's do 25 together. This is the one where you have the double digit divisors. Actually, no, it's not. Hold on. 25 is going to be divisibility rules, but let's back up a minute. I do want to show you one in your book. Let's do one like number 24. This is on page 92. This is not what you're doing today.
Come on out. Bye-bye. Happy weekend.
But it is something that I do want to review with you. So let's do like this. 17 goes into 35 2 times. 17 times 2 is 34. 35 minus 34 is 1. Bring down the 0. 17 goes into 10 0 times. 17 times 0 is 0. 10 minus 0 is 0. I'm sorry. Whoop, let's back up. 0 minus 0 is 0. Sorry. Then bring down the 2. 17 goes into 2. Let's back up because Miss Clark messed up somewhere with it being so loud around here. All right, 17 goes into 10 0 times. 17 times 0 is 0. 10 minus 0. All right, we messed up somewhere. Let's start over. Sorry. This is what happens when we have a live video. Let's start over on this one. It gets very distracting on Friday afternoons at carpool. So 17 into 35, 2. 17 goes into 35 2 times. 17 times 2 is 34. Let's make sure Ms. Clark is right on that. Yes. Minus 1. 17 goes into 10 0 times. 17 times 0 is 0. 10, bring down the 2. All right, now 17, we need to go off to the side and see how many times it goes into 100 too. So let's try 6. 6 times 7 is 42. 6 times 1 is 6, plus 4 is 10. So it goes in 6 times. 17 times 6 is 102. You would subtract that, get 0. So our answer is 206. So when you have these double digit divisors, sometimes you'll have to go off to the side and do some extra work. All right, so today with 25, remember that was just kind of a extra little bit. You will have to work on some divisibility rules. Divisibility rules is what we did right before break. So remember what those were. Remember, a number is divisible by 2 if the last digit is even. If you add up the numbers like this, so say we have something like 431. To see if it's divisible by 3, I add them up. 4, 5, 6, 7, 8. I cannot divide 8 by 3, so 431 is not divisible by 3. Same with 9. If I do 4 plus 3 plus 1 equals 8, I can't divide 8 by 9, so 431 is not divisible by 9. If the last 2 digits can be divided by 4, the whole number can be divided by 4, so that one doesn't work. If the last number is a 0 or a 5, it can be divided by 5, and if 2 and 3 work, then 6 works. So remember your rules, go back and look at them in your book. You will have to fill in the blank on one of them on your test. So that's 25 through 32, and then 41 to 44 is order of operations. You're not really going to have any of the expression stuff on it. It's going to be more order of operations. So let's do 41 together. So we have 36 minus 3 times 7 plus 10 divided by 5. Remember, parentheses first. 36 minus 3 is 33. So I'm going to rewrite all of that. Next, I do multiplication or division, whichever one comes first. 33 times 7 comes first. So I'm going to go and solve that to the side. 7 times 3 is 21. 7 times 3 is 21, 22, 23. So I get 231 plus 10 divided by 5. Next, I want to do 10 divided by 5 is 2. 231 plus 2 is 233. So that one we did together. So you'll do 42 through 44, and that'll be it. And then you'll be ready for your test. I'm not going to make a video for Wednesday just because it's test day. So the next video you see will be Thursday's video. So good luck on your test. Let me know if you need any help with it. All right, this is Thursday's video. Yesterday you had your test, and today we're going to start our new chapter in our new lesson. So we're going to be on page 98 and 99. So 98 and 99. I'm actually going to go ahead and make this video for Thursday and Friday because it's the same thing, so it would be a little bit easier just to watch this one. So let's say this is Thursday and Friday's video. Same thing you're doing for both days, just a different classwork assignment. So on page 98, let's look at the top because there are some notes things you have to know. A prime number is a whole number whose only factors are 1 in itself. So if you have a prime number, you can only get to that number by multiplying it by itself. So for example, 6. I can multiply 2 times 3 to get to 6, or 1 times 6 to get to 6, so it's not prime. Any numbers that are not prime are called composite. So a number can be either prime or composite. It says composite numbers are whole numbers that have more than 2 factors. 1 is neither prime nor composite. So you need to know that. 1 isn't prime or composite. Okay, so 1 is not prime or composite. You can use let's go back up to the second paragraph. You can write a number as a product of all its prime factors. This is called prime factorization of a number. Don't let that word scare you. You can use a factor tree to find the prime factorization of a number. To use a factor tree, write the number as the product of two factors. Repeat the process until the factors are all prime. So it's basically similar to order of operations where you're starting big and getting smaller. So let's do prime factorization of 48. So the first thing you do is write 48. Then you think, what two numbers make up 48? 6 times 8. So 6 times 8 will make 48. Then I'm going to break down the 6. What two numbers can I multiply to get 6? 2 times 3. Then I'm going to think, what two numbers can I multiply to get 8? 4 times 2. Now for these, if I can only do 2 times 1 or 3 times 1 to get 2 and 3, that means they're prime. I can't go anymore. So I'm going to leave 2 as it is, because if I kept writing 2 times 1 over and over, we would keep doing it. We're going to leave 3 as it is. 4, I can say 2 times 2 equals 4. 2, leave by itself. So the prime factorization of 48 is 2 times 3 times 2 times 2 times 2. We can shorten that by counting up how many 2's we have and using exponents. So we only have 1 3. I'm going to put that right here. We have 1, I'm going to use my yellow, 1, 2, 3, 4 2's. So to show that in prime factorization, I'm going to say 3 times 2 to the 4th power. Both of these are correct, but the top one is a better answer. So all we did is break 48 down into the prime numbers. Prime numbers means that I can only multiply by that in itself to get that number. I can only do 2 times 1 to get 2. I can only do 3 times 1 to get 3. However, 6 is not a prime number. It's composite because I can do 2 times 3. I can do 6 times 1. Same thing with 8. So prime factorization is what I circled in green. That would be your final answer. So let's do number 1 together. In your book, we're on 98. We're going to do number 1 together. The best way to do these is to keep practicing the same way it is with all math. You still have to know your multiplication facts. We're still doing multiplication here. So they give us 18. We're going to do this 2 ways because there are multiple correct answers. Well, there's one correct answer, but multiple ways to get to it. So for 18 and 6, for 18, I can do 3 times 6. For number 3, I can't break 3 down anymore. The only thing I can do is 3 times 1. So that one's done, it's prime. For 6, I can do 3 times 2. Those two numbers are prime. So my prime factorization is 3 times 3 times 2, or 2 times 3 squared. That squared, that number right here I'm circling, is because I have 2 3's. Now I could do it like this. 18 is 9 times 2. 2 is prime, so I'm going to leave it as 2. 9, you get 9 by doing 3 times 3. Oops, sorry, it doesn't want to work. So I get the same answer. So it doesn't matter which factors you use to get to the number they give you, as long as you get the correct answer in the end. So let's do another one together. All right, let's do 90. So you would think to yourself, what two numbers equal 90? 10 times 9. Okay, then what two numbers do I do to get to 10? 5 times 2. To get to 9, I do 3 times 3. All of those numbers are now prime. Those numbers I cannot break down any more than they already are. If I broke them down anymore, I could do 5 times 1 is 5. Well, then I have to break down 5 times 1 is 5 again. It just keeps going. So stop when you get to a prime number. So now to do the prime factorization, I could say 2, so I use that one, times 3 squared, because there's 2 3s, and there's only one 5, so I'll put times 5. Okay. They're not as hard as they look. It does look a little daunting because it's something new, but as long as you know your multiplication facts, it's almost like a little puzzle. You're breaking them down. All right, let's do 72. So to get 72, we would do 8 times 9. Number 8 would be 4 times 2. 9 would be 3 times 3. 4 is 2 times 2. And then we're going to break that down to 2. That stays 3. That stays 3. So now we have 3 2s. So I'm going to say 2 cubed times 2 3s, so 3 squared. And that would be my final answer, what I have in green right here. Okay, so that is what prime factorization is. So on today's classwork, Thursday's classwork, you're going to do 4 through 11. 4 through 8 is just saying whether a number is prime or composite. So let's go back to that for a second. Let me give you a few more examples of that. You have to know your factors, which are just multiplication facts. If you don't know them, you cannot do this. So if I have a number like 54, I know it ends in an even number, so I know that I can divide that by 2. I know that 9 times 4 is 54, or 9 times 6, sorry. 9 times 6 is 54. 54 times 1 is 54, so this is prime. If I looked at the number 7, the only way I can get to 7 is 7 times 1. I'm sorry, go back. This is composite. I'm messing you guys all up. The only way I can get 7 times 7 is 7 times 1, so it's prime. If I have a number like 23, the only way to get to 23 is 23 times 1, so it's prime. If I have 24, it's composite because I could do 6 times 4, I could do 12 times 2, I could do 24 times 1. All of those ways get me to 24, so it's composite, okay? So you're going to do that for 4 through 8. You're just going to say whether it is prime or composite, and if you want to put P or C, that's totally fine. For numbers 9 through 11, you're going to do a factor tree. So for numbers 10 and 11, if you look at it, they give you 350 and 270. Think about breaking that down as 35 times 10 and 27 times 10, and then break it down from there. Don't get scared because it's a bigger number. Look and see if you can break those down. So that's a hint on 10 and 11 for Thursday's classwork. Thursday's homework is workbook page 73. Friday's classwork is 12 through 16. It's the same thing, making the factor trees. You might have bigger numbers where you're going to have to do some guess and check to see which factors make it up. This is where divisibility rules come in. If you look at a number, let me erase this, I have a little bit of room. If you look at a number like 127 and they want us to make a factor tree with it, I know that it doesn't end in an even number, so I can't do something times 2. It doesn't end in a 0 or a 5, so I can't do something times 5. Let's add it up. 1 plus 2 plus 7. 7, 8, 9, 10. Can't do 3 or 9. But you can, actually that probably wasn't a good example because I don't think there is one. That might be a prime number. So let's look at something like 147. I think that's the one you're actually going to have. Doesn't enter an even number, can't do 2s. 5's not going to work. Let's add it up. 7, 8, 9, 10, 11, 12. It ends in 12. So if I was doing a factor tree for 147, I know that I can do something times 3. That number is what you're going to need to find out before you can go any further. The way to find that out is doing 3 into 147. So all the stuff we learned in chapter 5 comes into play here. You have to know how to divide, and you have to know your divisibility rules for bigger numbers like this. Now, if I give you a number like 24, you can break that down. You know what two numbers make 24. Okay, so you're gonna have to use what you know to figure these out. Okay, so this is the end of the video for the week. Let me know if you guys have any questions, okay? Have a good weekend.